Okay, now we'll be going on to topic 4. Only 3 topics left. And they're particularly using the FOIL method here. Well, had I looked, I would have done the other ones the other way, but in the lesson, again, it comes in the whiteboard where I'm lecturing, I do cover that in some detail. So, let's do the FOIL and see what happens here. And I'll lay out some of these so you can really see what's going on here. So first, x squared. Outers, a positive 1x. Inners, 4x. 4x plus 1x, I'm doing this mentally, 5x. And then last, plus 4. Now in the next course that you take, you'll be taking this and unfoiling it back into its factors. First, 3x squared. Now my outers are a 6x. My inners are a negative 11x, which gives me then a negative 5x. I did that mentally. And then my last is a negative 22. And it never hurts to check. So there's 3x squared, a positive 6, a negative 11, a negative 22. That's good. So that's going to be a 4x squared. Outers are a negative 20. Inners, a negative 11. That's going to add up to a negative 33x. And this is going to be a positive 65. Now here, because this is an x squared, we're not going to get like terms in the middle. So we can still FOIL it. This is y to the third. My outers, a negative 8y squared. My inners, a positive 7y. And my last, a negative 56. And again, this is through a FOIL, but I'm not sure we're going to get like terms. Let's see. All right, this one gives me an a cubed. Outers, yeah, we don't get like terms in the middle, so they're different. And then last, number 6, we'll give it a FOIL. Now, since they're like terms, it's going to be a lot easier to handle. Our outers are a positive 1/12. Our inners are a negative 7/12. So I end up in the middle with a negative 6/12 that can be reduced to 1/2. And then I get a negative 7 over 144. Okay, that's good. Now, this we could do by regular FOIL as well. So 5 times 2 will be 10. And my outers will be a negative 40. Oh, no, I'm sorry. I'm doing the wrong ones. 5 times 5 is a negative 25. Let me write that. Negative 25a. My inners are going to be a negative 16a. And I should be able to do that mentally, but I wrote it out anyway. Again, write them out if you need to. And that's going to be a negative 41a. And this is going to be a negative times a negative makes it a positive 40a squared. Okay, we're going to FOIL this. Notice they added another letter. Still not a problem. That's going to be 3x squared. Now my outers are a negative 5. My inners a positive 21. So that looks like a positive 16. But xy now. Then my last is a negative 35 y squared. And that is correct. Okay, so as we look at these, we're using that special technique of FOIL. Now remember, FOIL is just a process in which you multiply the first, the outers, the inners, and the last, which then covers everything. And often the two middle terms join to form common terms. So it goes from a 4-term polynomial to a 3-term polynomial. In some cases they don't, but in most cases they do. All right, let's pause, raise it up. Now again, we're going to use that special technique of squaring a binomial. So we square the first term, multiply these two together, that gives you 100x. Now double it, that gives you 200x. And you square 100, and that should give you 10,000. All right, this one's a little tricky because of the decimal here, but we're squaring the first. That'll give us x squared. We're going to multiply these together. That gives us a 10.5x. Double it. That's going to give us a positive 21x. And now we're going to square this next one. And that will be 110.25. All right, we're going to square 15a, and that gives us 225a squared. Going to multiply 2 times 15a and get a negative 30. And we're going to double that. That'll give us a negative 60a. And then square the negative 2, which would give us a positive 4. All right, here we get square the y. Now we're going to multiply these together and then times it by 2. So that gives us a negative 10 ninths y. And then we're going to square this last term, and we get a positive 25 over 81. And now we're doing this one. Square that. That's going to be a 25y squared. Now, 5 times 12, I believe, is 72. No, 5 times 12 is 60. That's better. Doing this in my head. So I double 60. I get a negative 120y. And now I square negative 12 times negative 12 is a positive 144. Now all of these, when we square a binomial, give us a product, these out here, that are called perfect square trinomials. Now an interesting thing about them, the first terms of all of these are perfect squares. And the last terms of each of these, although this one's kind of a tricky one, are perfect squares. And if you look at the middle sign, that is the middle sign of our product out here. So later in your next course, you'll be asked to recognize perfect square trinomials. They are designated by having the first and last term be perfect squares. And then if you take the square root of that, which is 100, and double it, you get your middle terms. And it's kind of complicated at this stage, but again, all you need to know is how to square binomials. Now, in the next few examples, a new word that we introduced in the lecture, you might recall, is a conjugate. A plus B times A minus B. When you are multiplying the sum and difference of the same terms, these terms in here are called conjugates. And when you multiply conjugates, the middle terms cancel out. We get a squared minus ab plus ab minus b squared. Now you notice as you do your outers and your inners, they're the opposite of each other. So this ends up as a squared minus b squared. This is the product of conjugates, is the difference of perfect squares. So when we do this, we only have to multiply, and we recognize they are conjugates, the first and the last. And when we factor the difference of perfect squares, which comes in the later course, you'll get their conjugates. So this will be 36x squared minus 1. And this will be 9x squared minus 225. And this will be 64y to the fourth minus 25. And this will be 49x squared minus 4 49ths. Now notice, each of our first terms are perfect squares. Each of our last terms are perfect squares. These are the difference of perfect squares that later will factor into their conjugates. So in the last two, we're asked to find the area of a rectangle rug by these dimensions, so we'll FOIL. This will be 7x squared. Our outers would be 21. Our inners a negative 5. That gives us a positive 16x. And then our last is a negative 15. And this one is a square with this as the measure of the side. So we'll use our new technique of squaring a binomial. This is going to be 64x squared. Multiply this together, get a negative 8x, double it, negative 16x plus 1. a perfect square trinomial. And by the way, these are all squares that we put after it too. Well, that wraps up this. Just 2 lessons left to do.